Okay, section 6.3, we're going to use a method called separation of variables. We've done this, something similar to this earlier in the year, but this is going to be a technique that we use to, get the pen, solve differential equations where they involve x and y. So before we go through and talk about how this works, earlier in the year we had problems where it was dy dx is equal to negative 6x squared minus 3. And that's the differential equation, meaning the derivative. And they asked us early in the year to find out what the original equation, what f of x was. So what we did, if you remember, we got dy by itself. We did negative 6x squared minus 3 and moved the dx over. And then we just integrated both sides and we solved that problem. We're going to be doing the same thing, but if you notice over here in this left-hand column, functions, the equation's kind of messy here, this differential equation. And the key to doing these is to be able to get everything that's in terms of y on one side of the equal sign and everything in terms of x on the other side. All right, so this first example here, and I'm not going to go through every one of these situations, but basically here's our differential equation. And by using separation of variables, we get to this where everything in terms of y is on one side and everything in terms of x is on the other side. So I'll show you how that happens for this first one. You have an x squared plus 3y dy dx is equal to 0. All right, so the first thing I'm going to do is move the x's to the right-hand side. So I'm going to go 3y dy dx equals negative x squared. And now since this is all multiplication on the left-hand side, I'm going to multiply both sides by dx. And I get 3 dy equals negative x squared dx. And now they're on both sides, and what we're going to do at this point, we're going to integrate both sides of this function. Okay. All right, so, and again, I'm not going to do these next two to show how you separate the variables. We'll just get to doing some problems here. Okay, so they're going to ask us to find the general solution. So here's our differential equation. Notice it's in terms of x and y on the right-hand side. So to find the general solution, we want to get the x's and the y's together on the same side, and then we're going to integrate. So the first thing I'm going to do is multiply by dx. I'm going to get dy equals x, y times dx. And now I got to get the y to the other side, so I'm going to divide by y, divide by y. So I have dy over y equals, these y's cancel out, and x dx. Okay. Now I'm at this first problem here. So to know that you watched it, the next time we're in class, you have to come up to me, or when we're sitting down, and you have to give me the code word. And when you say the code word, I'll know you've watched it. And the code word is FTOC. FTOC. Okay? Fundamental Theorem of Calculus, but you got to say FTOC. And don't tell your friends if they didn't watch it, because I don't know who watched it and who didn't. Okay, so now to continue here. We're going to integrate both sides. All right, so when we integrate this left-hand side, and actually let me rewrite this because it's really 1 over y dy. Might be a little bit more comfortable with it looking that way. All right, so the integral of 1 over y dy is the same thing if we integrated 1 over x dx. So it's the ln absolute value of y plus c, and I'll tell you how we're going to deal with the c's on both sides. And then the integral on this side is going to be x squared over 2 plus c. Now, since I have a constant on both sides, really what you're eventually going to do is you're not going to write it on both sides. It's almost like we're going to subtract a constant, and we'll just have a constant on the right-hand side of the equation. So this is going to become ln absolute value of y equals x squared divided by 2 plus c. So again, when you get good at these, you're not going to really necessarily write that plus c there. Just going to put it on the one side. Okay, so now let me rewrite this up here. So we have ln absolute value of y equals x squared over 2 plus c. Now remember what we're trying to do. We're trying to find the general solution, which is we want to come up with the original function. All right, now this is where it gets a little bit messy. We're going to exponentiate both sides of this, and we're going to do, the base is e. Okay, so we're going to exponentiate that. Now what this left-hand side becomes is, these are inverses, base e and its exponents, the natural log, undo each other. So I get the absolute value of y, and it's going to be e raised to the x squared over 2 plus c. And that whole thing is an exponent. Okay, now I have to show you how that right-hand side simplifies. All right, let me backtrack a little bit to, let's say, Algebra 1. When you had an x to the a times an x to the b, where the bases were the same, you wrote down the base and you added the exponents. So what's actually going on here to this part is the way that we got to e to that power is you're really doing e to the x squared divided by 2 times e to the c. Now I know you're thinking it should be a plus, but here's how a plus becomes a multiplication, right? All right, so what ends up happening, I still have my absolute value of y here. So my absolute value of y is equal to, I'm going to leave a little space here, e to the x squared. E to the c, now remember c is a constant, and if the base is e, which is 2.7128, well that whole thing is a constant. So what we're going to do is rewrite that out in front as a big C for a constant. Now, this absolute value technically disappears, and again, it's going to be kind of when we learn how to do these, you're just going to rewrite it without the absolute value. But really what's going on here is y can actually be equal to plus or minus c e to the x over 2. But the plus and minus isn't going to matter because it's just some constant anyhow, so whether it's positive or negative, we'll find out when we go to solve for c. So your final answer for this is y equals c e raised to the x divided by 2 power. And that's the general solution to that problem. The specific solution is, depending on what x and y is, we're going to come up with the specific solution so we can figure out what c is. Okay? And that's pretty much how they all work out. Some of them are more difficult than others. So here, let's do this next one. Write it in terms of dy dx, get the x's and y's together, and then we're going to integrate, find the antiderivative of both sides. So this is going to be dy dx, and it's convenient to write y prime and dy dx because we want to separate the variables, is equal to 2x over y. So we can really just cross multiply here and get y dy equals 2x dx. And now we're going to integrate both sides. So the integral, remember the secret password is FTOC, don't forget it. Actually, you know what? I'm going to change it because you know what? I think some of you are going to stop listening after I told you the password. So the password now is implicit differentiation. Implicit differentiation. Okay, so now when we integrate this, we're going to get y squared, and I'm not going to put a, over 2. I'm not going to put a plus c, is equal to, and this is going to just become an x squared plus c. All right, so now I'm going to solve for, well, there's a couple of ways they write this equation. Sometimes I've seen it where they just solve for c and they write it as y squared over 2 minus x squared equals c. I've seen it written like that. I've also seen it written where they just solve for y squared, so you're going to multiply both sides by 2, so you're going to get y squared equals 2 times the quantity of x squared plus c, which is really just 2x squared plus c is y squared. And if you wanted to solve for y, then we can go y equals plus or minus the square root of 2x squared plus c. And again, just be able to write it in all three of these notations here. Okay. And I'll be specific on how I want it written. All right. So it's kind of the same thing each time. Get everything in terms of x on one side, get everything in terms of y on the other side, and then integrate. So let's see what we're going to do for this one. All right, so let's solve for dy. Actually, let me come over here. No, I'll go here. dy dx is equal to xy divided by x squared plus 4. And now I think I can cross multiply here. Let me come over here because I'm going to run out of room. So this is going to be x squared plus 4 times dy equals xy times dx. So I want to move this y over to the other side by dividing, and I can divide this whole thing. So let's see if I can do this all at once. So it's going to be dy over y when I divide by y equals, then I'm going to be left with an x dx in the numerator there, and that's all going to be over x squared plus 4. Let me write that a little bit nicer. So 1 over y dy equals x over x squared plus 4 times dx. And we're going to integrate. Alright, so this is ln absolute value of y, and then the plus c will be on the other side. And the antiderivative of this, we're going to have to use u substitution. So u is going to be equal to x squared plus 4. du is going to equal to 2x dx. So du over 2 equals x dx. So I'm going to rewrite this whole thing. I'm not even going to take the antiderivative yet. I have to write it in terms of u. So there's going to be a 1/2 out in front. Integrate. This is going to end up being a 1 over u du. Alright, so now I have ln absolute value of y equals 1/2 ln absolute value of u, which is x squared plus 4. Now that's always going to be positive, so we could lose this absolute value. And then a plus c. And now I'm going to exponentiate both sides. And again, the absolute value y is going to disappear. In this case, I showed y in that first example. So now we're going to get y is equal to e raised to the 1/2 ln, losing the absolute value because that's always going to be positive, and then plus c. Again, I'll show this one more time how this c comes out in front. So it's going to be y equals e to the 1/2 of ln of x squared plus 4 times e to the c. And again, that's the idea of a to the x times b to the y. I think I wrote it the other way last time, but it's going to be, that's wrong. I have to have the same basis. A to the y is going to be a to the x plus y. So what we're doing in this step is we're going from here back into this. Alright, so y is going to be equal to, that's a constant, so it's going to be c, and e raised to the, you can do that to the 1/2 power, but e to the ln 1/2 ln of x squared plus 4. And actually we can simplify that a little bit more, because if this is a base e and its exponent is the ln, we can simplify that to y equals c, and it just ends up being this to the 1/2 power. So x squared plus 4 to the 1/2 power, or y equals c times the square root of x squared plus 4. And there you have it. Okay, I think you should get the hang of this. I'm not going to do this entire one, but the first thing you need to do with this equation is multiply everything through by dx. So each one of these terms, so this is going to become xy times dx plus e to the negative x squared. Oh, this is one whole term. This is all multiplication. So just when I multiply this whole thing right there by dx, that dx is going to cancel out. So I'm left with y squared minus 1 dy equals 0. And now you're just going to do the same thing. You're going to separate the variables. I'm just looking at the work here and see if it gets kind of messy. Yeah, well, let me just see. I'm not going to do all the rest of these. There's 3 or 4 more.
Excuse the interruption for some more.
Okay. This one, again, is similar to the other ones. Separate the variables, and I'm running out of time here. So the next 3, numbers 5, 6, and 7, are all the same, where you have to find the equation of the curve. So they want you to find the particular solution through a particular point. So I will actually do number 6, and number 5 and 7 are similar to it. All right, so for number 6, they want you to find the particular solution. So the first thing I'm going to do is write this as anything that's y prime, I'm going to write as dy dx minus the ln of x squared equals 0. All right, I'm going to separate the variables. So I'm going to get 2x dy dx is equal to the ln of x squared. multiply by dx, since it's all multiplication on this side. Actually, I can multiply by, yeah, let me just do that. I'll do it this way. I will just divide by 2x, and now I'll multiply. So dy is equal to, I'm going to bring the 2 out in front, 2 ln of x over 2x dx. And these 2's are going to cancel out. So I'm going to integrate dy, integrate the ln of x over x dx. All right, so when I integrate this, I'm going to get a y. Now I have to use substitution for this. Now, this integral really here is 1 over x times the ln of x. So I'm going to make u equal to the ln of x. Therefore, du is 1 over x dx, and that kind of all matches up. So what this is going to end up becoming is the integral, the 1 over x dx is my du, and the ln of x is u. And now when I go to take the antiderivative of that, I'm going to get u squared over 2 plus c. I'll finish this up right here. I'm going to plug u back in, so y equals, u was ln of x squared over 2 plus c. And now they want me to find the particular solution, so my ordered pair is 1 comma 2, so I have to figure out what c is. So that's going to be 2 equals the ln of 1 over 2, that's squared, plus c. When I do the math for that, I get c equals 2. And now my particular solution, I have to plug it back into there, actually right here, to figure out what c is. So it's going to be y equals the ln of x, the whole quantity squared, over 2 plus 2. And that is your final equation. Okay? You should be able to handle 7 and 5 after showing that. All right, thanks.